Hello, dear students, welcome back. Hello. Hello, beta. Good evening. Am I audible? Am I audible? One second. Okay. So, as you know that we have started the 11 portion for your JEE and NEET 2026, and we completed lecture number first in last week. So, in this particular week, we will be starting continuous lectures on kinematics, then 1D, firstly 2D. Okay. So clearly, I guess I'm starting one more series for 12th. That series would be on numericals only because we had completed the subjective things, right? And I guess I will be starting a English lecture as well. So firstly, we will just continue this lecture, and if time permits, we will be discussing the plan with which we will be completing our syllabus. Okay. And if you have any doubts or any issues that you are facing, right, so you are having my Telegram group link below my video description part. You will find my channel's link. You can just send me a message. Okay. So I guess I need to start now. Lecture number 2nd. And in previous lecture, if you are present, so we discussed about what mechanics is all about, what is kinematics, and what is frame of reference, position, types of motion, distance, displacement. Numerical is based on distance, displacement, relation between distance and displacement, and also the directional problems. Okay, how to find theta if theta is given differently, how to do these numericals. And I have given you some homework numericals as well. I hope you have completed those things. If not, then let me know in the chat box or in my Telegram group. I will be sharing the solution part of this also. So let us now continue lecture number 2nd of kinematics. And I hope this screen is very visible to you. Okay, and if you have any doubts, you can just let me know. So let's start now. Lecture number 3rd of kinematics. Okay, lecture number 1st. Okay, lecture number 3rd, right? So lecture number 3rd. It is lecture number 2nd. No, not 3rd, lecture number 2nd. Okay. Now we will be starting this lecture with a very great topic, and that topic is known as speed. Speed. I'm not going to write the definition part because in your institutions or in your schools you have probably done this topic is very well, the definitions part, right? So here we will be discussing only those things which are very relevant to your examinations. Okay, so and at the end I will be sharing the notes. Okay, don't worry about anything. If you are in my group, you will find the notes of each and every class. Look now. Speed. What is speed? Speed is a rate at which speed means a rate at which distance is covered. Distance is covered. That means how fast or how slow you are walking or you are covering some distance with respect to time. With respect to time. Done. And speed is depending on distance. As the distance is a scalar quantity, so speed is also a scalar quantity. Speed is also a scalar quantity. Done? And we know one thing that, look, distance is only positive. Displacement could be positive, negative, and zero, but distance is always positive and increasing. In the same way, my speed is always positive. My speed is always positive. Always positive. And if we talk about unit, unit is meter per second. And if we talk about dimensional formula, so the dimensional formula of speed would be, there is no involvement of mass, so m0. Involvement of length, is there any? Yes, that is meters. There is L1, and there will be a T minus 1. Dimensional formula of speed. That's more than enough. Now we are having now types of speeds. Okay, we are having now types of speeds. So I will write here types of speed. First type means uniform speed. Uniform speed. Do you know what is the meaning of uniform speed? Huh? That means particle covers equal distance. Particle covers equal distance in equal interval of time. In equal interval of time. Done? So we know that speed is V equals to S by T. What is T? So T is time. What is S? S is distance. What is V? V is speed. So you will write speed is equals to distance by time, and uniform speed is particle covers equal distances in equal intervals of time. Look, we know one thing now. Let us suppose, I will give you an example now. Look now, a very basic example. Done? Look, if this is my track, if this thing represents my track, okay, and a radius of my track, particle is going like this, no? Let us suppose in anti-clockwise manner. Suppose, and suppose speed of particle is, suppose now at this instant it is 2 meter per second, this speed. Okay, V1. Here I will write V2. Suppose V2, now suppose it is also 2 meter per second. Here I will write V3. V3. It is 2 meter per second. Here V4. It is also 2 meter per second. I guess you have done this thing now, and this one is known as uniform circular motion. This thing is known as uniform circular motion. In uniform circular motion, the speed of particle is same throughout. Speed, not velocity. Speed is same. Velocity is different. And we know one thing that, sir, in uniform circular motion, only what? AC, centripetal acceleration is present. And in which my tangential acceleration, it is equals to 0. We're having two components of acceleration. Look, AC is responsible for direction. AC is responsible for direction, and AT is responsible for magnitude. Done? I am saying you, in uniform motion, is it possible that the particle is having acceleration? So you can write, yes, acceleration could be possible. So here I can write one thing, that acceleration may be present. I will write here, acceleration may be present. May be present. But which acceleration? This acceleration will be perpendicular. This acceleration, it will be perpendicular to the motion, to the speed. Okay, to the speed. Okay, write like this now. Okay, an example I will write here, uniform circular motion. This one. This point is an important one. Let's suppose someone will ask you, if you're going with uniform speed, so is it possible in uniform speed acceleration is present? So you will think, okay, if acceleration is there, there will be a force. If force is there, force will change the speed of the body. Okay, if there is a uniform, so there won't be any kind of change in speed, right? So you will write no acceleration is present. But the answer is, there may be an acceleration present, but that acceleration should be the perpendicular to the motion of your particle. So what is the example? Example is uniform circular motion. Done? Okay. So uniform speed is the second part, known as non-uniform speed. We are having non-uniform speed. Uniform means equal distance is equal interval of time. Non-uniform means unequal distance. Unequal distance in equal interval of time. Equal interval of time. Or equal distance in unequal interval of time. Unequal interval of time. Done? Okay. Now same numerical is here. Same question is here. So if somebody will ask you, is acceleration present? Non-uniform. So acceleration, we are having two types of acceleration. Done. One acceleration is AC, centripetal acceleration. One is AT, tangential acceleration. AT is responsible for what? Directional. Direction. If direction changes, here is acceleration AC present. If magnitude changes, so AT is present. Tangential is present. Magnitude. And this one is known as AC, or this one is known as A parallel also. A parallel. This one is known as A perpendicular. Perpendicular. So here, what about the acceleration? What about acceleration? Sir, you will write parallel acceleration is present. Parallel acceleration is present. Why? Because this parallel acceleration is responsible for magnitude change. This parallel acceleration is responsible for magnitude change. And in non-uniform speed, magnitude changes. That's why we are writing here parallel acceleration should be present. Then, now let us come to third type. It is average speed. This one is average speed. Average speed. Average speed, I will write here VAVG. AVG means average distance. Total distance upon total time. Total distance upon total time. Now in average one, now we are having some subtopics or subtypes, right? So we are having case number first. Case number first is if particle travels, if my particle travels distances in S1, S2, S3 up to so on Sn, and time interval is given as T1, T2, T3 and so on up to Tn, then my V average I can write as a V average as a total distance, that is S1 plus S2 plus S3 plus so on up to Sn whole divided by time T1 plus T2 plus T3 up to so on up to Tn. Done? I can write like this. Done now? Okay, look now. Now, second case. Case number second. Case number second. Case number second is if speed is given and time is given. And time is given. How to write average speed? Look now. That is V1, V2, V3, V4 and so on up to Vn is given, and T1, T2, T3 up to Tn is given. But the equation that we derive right now, that was V average equals to S1 plus S2 plus S3 up to so on up to Sn whole divided by T1 plus T2 plus T3 up to Tn. How to write now my equation by using these two parameters? One thing that we know, that is speed is equals to distance by time from 9th class. It is divided by distance by time. So distance speed is V, distance is S, time is T. Therefore, I can write S equals to V multiplied by T. So I can write now V average equals to S1 is V1 T1, S2 is V2 T2, S3 is V3 T3, up to so on up to V and Tn. Whole divided by T1 plus T2 plus T3 up to Tn. I can write like this, right? Easy? Done? Suppose, I will write here suppose now. I will change the color to highlight this condition, and this condition is very important. Suppose T1 equals to T2 equals to T3 and each and every T is equals to T. Each and everything equals to T. So can I write now here this equation V1T plus V2T up to so on up to Vnt whole divided by T plus up to T, up to N, sorry. So what I can write now, I can write here, I can take T common. So internally I am having V1 plus V2 plus V3 up to Vn whole divided by N times T. N times T. T cancel out. So therefore I can write V average. V average equals to V1 plus V2 up to Vn whole divided by N. This relation is important. This one. The reason being why this is important. Okay. Suppose if you are having in numerical, so I can write for two equal interval of time, two equal. That means equation that I am having now, V average, it will be equals to V1 plus V2 divided by 2. You don't need to write anything now. This formula we derive it, and now after a couple of things we will be discussing some numerical based on this particular derivation. That means, look, if something is given to us. What is given to us? If velocity is, if speed is given to us. Okay, so speed is given to us, and if equal time interval is present. Okay, suppose someone will ask you, a boy is running with 3 meter per second in first 1 hour. In second 1 hour, he is speeding 5 meter per second. What is the average speed? How you will find? How you will find the average speed? Sir, I guess if time intervals are same, so one formula is there that we need to sum these numerical values and divide by 2. You will write v1 plus v2 by 2, 2 plus 5 by 2. That is 7 by 2. Is it numerical now? So this thing you need to remember. Now second part. Case number, we're having case number third. Case number 03. If S1, S2, S3 up to Sn given, and V1, V2, V3 up to Vn is given. If in my numerical, if distance and speed is given, how to find V average? One formula that we are having, that is S1 plus S2 plus so on up to Sn whole divided by T1 plus T2 up to so on up to Tn. This is a general formula that you need to remember. Now here distance and time should be there, no? But I am having distance and speed. So what I can write now? Sir, we know that speed is equals to distance by time. This thing I know it, no? Speed is distance by time. So time is not that, speed is there, no? So can I write now time is equals to distance by speed? It is distance by speed. Yes, sir. So time is t, distance is s, speed is v. So I can write t equals to s by v. So right now, so therefore I can write v average. I will change the color now to just give it a different look. So v average is s1 plus s2. Look, s is given now, so I can write s. s1 plus s2 up to sn. Now look, t is not given, so I can write s by v. So I can write here t1 is s1 by v1 plus s2 by v2 plus s3 by v3 up to so on to sn by vn. It looks weird, no? This equation looks weird, right? But suppose if I will take only two intervals, right? I will take two intervals only. So, and if S1 equals to S2, both are equals to S. So, therefore, I can write V average equals to S plus S whole divided by S by V1 plus S by V2. I can write it is 2S whole divided by, I can take S common, it is 1 by V1 plus 1 by V2. SS cancel out. So, I can write here 2 whole divided by V2 plus V1 divided by V1 V2. So therefore V average came out to be 2 times V1 V2 whole divided by V1 plus V2. Done? That means we are now with two formulas. We are with now two. Mostly you will get numerical based on only two intervals. Mostly. Sometimes you will get three now. Then I will show you how to deal with those numericals. But generally you will get a numerical based on two intervals. If one interval is there in which timing is given, that means first half, second half, in which, let's suppose, first minute, second minute, in this way, if something is given to you now, you have to write v1 plus v2 by 2. If an equation is like that, if a person moves with this velocity, this speed for half distance and for this speed by half distance, write the formula. So look, sir, distance is given to us and distances are equal. So which formula you will write? 2 times v1 v2 divided by v1 plus v2. Suppose a numerical like that. A boy goes from his home to school with some speed and he came back with different speed. Find the average speed for average speed. So the distance from home to school and from school to home is equal, no? So you will write 2 times v1 v2 divided by v1 plus v2. Done? If this thing is done. So let us do some numerical thing. Came a very great segment known as numerical segment. I can write here a person, write with me, a person moves for 30 seconds such that for first 10 seconds he moves with 200 meter per second, and for next 20 seconds he moves with 100 meter per second. Find average speed. We need to find now average speed. So we have some formulas, right? One formula is total distance, total time. Second is there v1 v2 divided by 2. Third is there 2 times v1 v2 divided by v1 plus v2. Okay, I will write here numericals. First of all, you need to tell me what are the parameters given to us. Firstly, now look here. What are the parameters given to us? I guess t1, one timing, that is 20 seconds is given to us. Sorry, 10, no? Which one is 10? 1 second. 10 seconds. For 10 seconds, speed is how much? 10 seconds he moves with 200 meters per second. T2 is 20 seconds. For 20 second thing, V2 is given as 100 meter per second. Okay, now formula that we are having S1 plus S2 divided by T1 plus T2. Second formula, we are having V1 T1 plus V2 T2 divided by T1 plus T2. Third formula, V1 plus V2 divided by 2. Fourth formula, 2 times V1 V2 divided by V1 plus V2. This formula, when S1 equals to S2, both are equals to S. This formula, when T1 equals to T2, both are equals to T. This formula, when V and T are given. This formula, when S and T are given. So now, while looking towards the given parameters, you will understand that, sir, T and V is given to us. T and V, look, S and T, this is not given. So we have to apply this formula now. So can I write here V average equals to V1? What is V1? 200. T1, it is 10 seconds. V2, it is 100. T2 is 20 seconds. Whole divided by T1 is 10, T2 is 20. Done? It is 2000, it is 4000. Divided by 30. Cancel out, it is 400 by 3. It would be 133.3 meter per second. Easy or super easy? Easy or super easy, right? Then we are done with one numerical in which we apply some formula that we got right after first 2 slides. Now one more numerical. I don't write now language, I will write the parameters only. Look now. Is it visible? Yes. Suppose, okay, this one is visible now. This one is more visible, this color. Suppose, question is, a person moves with 55 km per hour and the timing is given at 20 minutes. For first 20 minutes, person moves 55 km per hour. Then he moves with 60 km per hour in next 20 minutes. Then person moves with 50 km per hour with next 20 minutes. next 20 minutes. Now you will find a system here. What, sir? Timings are same, timing same, timing same. If timing same, then which formula I need to apply? V average. So formula is, sir, V1 plus V2 plus V3 whole divided by 3. Okay, what is V1? It is 55. V2 is 60. V3 is 50 whole divided by 3. Done? It is 5. 5, 5, 10, 15, 16. 165 by 3. Okay. 5, 3, 1, 3, 3, 5s are 15, 15. So my answer came out to be 55 kilometer per hour. $165. Mohammed Vahi, great beta. I guess you have done this unit right. Okay, next numerical. Next numerical. I am not writing the language now. Okay. We are having a track of 100 meters. The total length of track is 100 meters. Okay. Person divides the track into two equal parts, 50 meter and 50 meter. Done. In first 50 meter, his speed was 20 meter per second. In second 50 meter, his speed was 40 meter per second. Find average speed. Find average speed. Look, if unit is minute, na, look here, na, there is no involvement of timing, right? You are saying me here, it is kilometer per hour, right? But there is no involvement of timings, right? Look, we have not entered a single things na, of timings, right? It is V1, V2, V3 by 3. No involvement of timing. But timing is same. If I have given you in first 20 seconds, then 20 seconds, then 20 seconds, 20 minutes, 20 minutes, 20 minutes. If 20 hour, 20 hour, 20 hour, you need to only observe the instructions, right? You need to match it with the previous things. Previous thing was, if the timing interval is same, if the time interval is same, okay, sir, time interval is same, then we don't need to enter timing thing now. We need to just give the velocity, the speed one now. Do this numerical now. A person is going on a 100-meter track, but half the distance he cover with 20 meter per second. Next half distance he cover with 40 meter per second. Find average speed. Find average speed. Okay, sir, look now. Distance is same. SS is same. If distance is same, I guess I am having the formula. V average is nothing. It is 2 times V1, V2 divided by V1 plus V2. 80 by 3. Give me on in point is na? Huh? Done? I don't know the answer. Okay, look now. So I hope you have applied the same formula. It is 2. What is V? V is 20. What is V2? V2 is 40. Whole divided by V1. V1 is 20 and V2 is 40. So look now, I can write 2 into 20 into 40 whole divided by 40 plus 2, 60. 0, 0 cancel out. 2 1s are 2, 2 3s are 6. Okay. Now we're having, it is 80. It is 80 by 3. Okay. Yes, 80 by 3 is correct answer now. 3 1s are 3, 3 2s are 6. 20, 26. I get 26.6. Unit is meter per second. Done? Easy or super easy? Easy or super easy? Super easy, no? Okay, next numerical. Next numerical. Numerical like A person goes from his home to market. Person goes from home to market. And the going speed was 400 kilometer per hour. Okay. And he finds market is closed. He finds market is closed. Then he came back towards home with speed of 600 kilometer per hour. Find average speed. Find average speed. Sahal? बहुत sahal. Sahal means easy, na? Look, we are increasing level, na? Look, first of all, we derive the basic formulas. Then we go from basic level to increasing some sort of toughness. And that up to that toughness which is required for your examinations. I'm not giving you some different, some Olympiads one. I'm not giving those numericals to you because you're preparing for NEET and JEE means only, right? I am giving you to the point question and to the point solution of it. At the simplest way to explain anything. Okay, so look now, if you are going from home to market, coming from back to the same path, right? That means distance is same. If distance is same, so the formula is 2 times v1 v2 divided by v1 plus v2. So this 2, what is v1? v1 is 400, v2 is 600, whole divided by v1 is 400, v2 is 600. I can write 2 into 400 multiplied by 600, whole divided by 6 plus 4000. 2 0 2 0 cancel out, 1 0 1 0 cancel out. So we are having 2 multiplied by 40 multiplied by 6. It is 80 multiplied by 6. Yes or no? 6 zeros are 0. 48. Yes. It is kilometer per hour. It is 480 kilometer per hour. Now, let us increase some toughness of numerical, some toughness. But I will write the whole numerical, Numerical is a person moves such that he covers first half. He covers first half distance. He covers first half distance with speed 4 meter per second. And in a remaining half distance, he moves first time with speed 3 meter per second, and remaining half, look, a person moves first half distance with speed 4 meter per second, and in remaining half distance he moves first time with speed 3 meter per second, and remaining half time with speed 5 meters per second. Find V average. Now this one is little bit complicated. You know why? Because if the path is given as S, half is S, this half is S. Now this half S is divided into two parts, T into T. Here this speed V1 is given as how much? 4 meter per second. Okay, now this half is V2 is given as how much? 3 meter per second. Here V3 is given as 5 meter per second. How to apply the formula now? It is very simple and very easy as well. Look now. I guess here timings are same. If timings are same, so in this interval I will write v1 plus v2 divided by 2. Okay, so between these two intervals, what is v average? V average is v1. V1 is 3, v2 is 5 divided by 2. 5 plus 3 is 8, 8 by 2 is 4. It is 4 meter per second. Now I can write the whole thing now like this. Half distance, half. This one is with 4 meter per second. This one is with 4 meter per second. Now how to write it now? Look, distances are same. Formula is 2 times v1 v2 divided by v1 plus v2. 2, v1 is 4, v2 is 4 divided by, it is 4 plus 4. Okay, 2 into 4, it is 8. 4 ones are 4, 4 twos are 8, 8 it cancel out. So my answer is 4 meter per second. 4 meter per second. Easy or super easy? Easy or super easy? Huh? Okay. So I guess we need to increase now more toughness. More toughness now. More toughness. Okay. Look now. More toughness. If you want, I will be giving you the more tough numericals. Okay. Look now. Numerical. A man walks on a straight line road from his home to market 2.5 kilometer away with a speed of 5 kilometer per hour. Finding the market is closed, he quickly turns and walks home with speed of 7.5 kilometer per hour. The average speed of the man. The average speed of the man over the interval of time 0 to 40 minutes is equal to. This thing we need to find out. This one is a +1 numerical, a good one. A man goes from his home to market. The distance between the two is 2.5 kilometer, and he goes with the speed of 5 kilometer per hour. And when he finds the market is closed, he came back with speed of 7.5 kilometer per hour. So average speed, we need to find out the average speed of the man, but not in the entire journey. We need to find only between 0 to 40 minutes. 0 to 40 minutes. Sir, how we can do it? Okay. First of all, we have to find up to what 40 minute is valid. That means, look now. This is my road, home, market. Person goes with speed. Speed is how much? 5 kilometer per hour. So what is time now? And distance is 2.5 kilometer. We know that speed. One thing that we all know now, that is speed. Speed is equals to distance by time. So we need to manipulate the time term. So I will get time equals to speed. Speed is how much? It is 5 kilometer per hour whole divided by speed. No, time, it is distance by speed, sorry. It is distance by speed. So here time is distance is how much? It is 2.5 kilometer. Whole divided by speed is 5 kilometer per hour. Done? Easy now? So you will get 0.5. That means you will get 30 minutes. 30 minutes. That means person goes from home towards the market, he spends 30 minutes. 30 minutes. While coming back, T1. What is T2 now? T2 is distance is 2.5 and it is 7.5. 7.5. Okay. So when you will find 50 minutes. 50 minutes. Done? Easy now? So you have 20, sorry, 20 minutes. So 30 and 20 minutes. Whole journey. So total time is T1 plus T2. So the whole journey came out to be 30 plus 20. It gave to be 50 minutes. But we don't need 15. We need only 40. That means 30 minutes and 10 minutes. So I will, let us suppose, up to this particular point. So we need to write V average as V1 T1 plus V2 T2 whole divided by T1 plus T2. What is V1? First speed. First speed is how much? 5. I can write 5 kilometer per hour. It is 30 by 60. 30 minutes, 60 minutes. It gives R, right? Plus V2. What is V2? V2 is 7.5. 7.5. Multiplied by, we only need 10 minutes, no? Not only 10. Why? Because 30 plus 10 is 40. So I can write 10. 40, right? 10 divided by 60. Whole divided by T1. What is T1? 40. It is 40 divided by 60. So what is V average now? Look, ones are, twos are, ones are 6. It is 5 by 2 plus 7.5 divided by 6 whole divided by 4 by 6. 5 by 6, right? So when you will do all this calculation, you will find 5.6 kilometer per hour answer. A good numerical. This was a good numerical. You cannot write now Sahal 1. Okay? You cannot write now Sahal 1. Done now? Okay. So now we are having now with instantaneous speed. Instantaneous speed means speed at a certain instant of time. If I will just ask you now, let us suppose, give me the speed of a person at t equals to 4 seconds. That means at particular 4 seconds, what is the speed of your person? Okay, if I just give you an example of a speedometer of your car, it is going now. So when you are just pushing the acceleration part, the acceleration one in a very great push, you will find a great reading. It is fluctuating each and every second. So the reading of that speedometer gives the instantaneous speed. Okay, and it is equals to speed limit delta t tends to 0 delta s by delta t, or simply ds by dt. Done? How, sir? So you will find a numerical. Suppose my x is 2t cube minus 4t plus 5. Okay, find speed. So nothing, just differentiate this one. Look, 3 to the, it is 60 square minus 4. If I will tell you find the speed, this speed, now find the speed at t equals to 1 second. So you will write 6 multiplied by 1 square minus 4. It is 6 minus 4. That means it is 2 meter per second. Easy differentiation, nothing more than that. V is dx by dt or ds by dt, nothing more than that. Clear? One more numerical. Numerical is, if s equals to 4t square, if s is given me as 4t square, first part, find speed at t equals to 10 seconds. That means at this interval you have to find speed. So I can write ds by dt. This will give me speed which is equals to 4 to the 8t. So speed at t equals to 10. I can write 8 multiplied by 10. Answer is 80 meter per second. Second part, if I will give you the question as average speed from 0 to 10 seconds. From 0 to 10 seconds, how to find the average speed? Simple. What is the average speed now? I can write V average, distance by time. Okay, or I can write x5 minus x initial by t. What is x final? It will be 4t. It is 10 square minus 4 0 square divided by it is 10. It is 400 by 10. Answer is 40 meter per second. Easy or way more than easy? One more numerical. One more equation. If it is given as 4t square plus 5t minus 6, find initial speed. Initial speed means when t equals to 0. So I can write ds by dt. It is 4 to the, it is 8t plus 5. So v at t equals to 0, it is 8 multiplied by 0 plus 5. So my answer came out to be 5 meter per second. Easy? Or if I just give you the speed, find speed at t equals to 4 seconds. I will write 4, it is 8 multiplied by 4 plus 5, 32 plus 5, 37 meter per second. Okay, with this topic we completed the speed portion. Now let us start velocity now. Let us start now velocity. Velocity. What is velocity? What is velocity? It is a rate of displacement. It is a rate of displacement with time. That means how fast or how slow you are going with what particular direction. Velocity is speed with direction. In what particular direction you are going. That means net displacement with time. It is not distance by time. Distance by time means speed and displacement by time means velocity. Okay, and velocity depends on displacement. Displacement could be positive, negative, 0, and that is a vector quantity. So velocity is a vector quantity, and my velocity could be positive, my velocity could be negative, and my velocity is 0 also possible. If we talk about unit, it is meter per second, same as distance. And if we talk about dimensional formula, it is LT minus 1, same as distance. Now we are having types of velocity. One second. Okay. Now First type, uniform velocity. Uniform velocity, it is also equals to uniform motion. Uniform motion, uniform velocity is also equals to uniform motion. If you will write, if the magnitude of the magnitude of any motion and direction, magnitude as well as direction, if it remains constant, that means straight line motion. If a car, bike, a person is moving with a constant speed in a one single direction, not changing any direction, this particular thing is known as uniform velocity. Suppose a person is going with 2 meters per second in east direction, with same speed, 2 meters per second in each direction. So this type of velocity is known as uniform velocity or uniform motion. And uniform motion, one thing is there, acceleration must be zero. Acceleration must be zero. Do you know why? Because in acceleration we are having two parts. We are having AC and AT. AC is responsible for direction and AT is responsible for magnitude. Look here, we don't need direction change, we don't need magnitude change. That means no acceleration should be present. And if acceleration is zero, that motion is known as uniform motion. Acceleration is zero. Second type motion, velocity, it is non-uniform. It is non-uniform. It is non-uniform velocity. What is non-uniform velocity? If my magnitude changes, if direction changes, or both, this particular thing means non-uniform velocity. For magnitude change, AT must be present. For direction change, AC must be present. So you will write here, acceleration is present. Must be present. Acceleration must be present. Done? Third one now. Third type is known as average velocity. Third one is known as average velocity. What is average velocity? You will write net displacement. Net displacement to total time. Total time. Net displacement by total time. V average. This is vector. Net displacement divided by total time. This thing represents average velocity. Fourth one, instantaneous velocity. What is instantaneous velocity? That means at a particular instant, at a particular instant of time. Instant of time. You can write V equals to limit delta t tends to 0, delta s by delta t, that is ds by dt. These are very usually using equations in kinematics, right? One important point is there. if we are talking about uniform velocity, if uniform motion or uniform velocity, if we are talking about uniform motion or uniform velocity, so you will write it is V average. Average velocity is equals to the instantaneous velocity. This point, right? If we are talking about a uniform motion or uniform velocity, in uniform motion or in uniform velocity, instant velocity is equals to average velocity. You need to write these things for your examinations. You need to find something like that, no? If uniform motion is there, V average, V instant, is there a relation between V average and V instant? Okay, now let us merge two concepts. One concept is speed, one is velocity. Let us merge these two concepts now. A particle moves along a semicircular path of radius 5 meter from point A to point B in 2 seconds. Then find, first thing, average speed. So if we are having a semicircular path like this, and its radius is equals to 5 meter. 5, this one will be 5. And time taken, a person goes from A to B and time taken is 2 seconds. What is average speed means? It is distance by time. What is distance? Sir, 2 pi r is whole, it is pi r only. It is pi into r divided by time t. Pi is pi, r is 5 divided by t. T is how much? It is 2 seconds. It is 5 by 2 pi. That means 2.5 pi meter per second. So if somebody will ask you what is average velocity? What is average velocity? Average velocity is displacement. Average velocity is displacement by time. So displacement of this semicircular path, we had done it in class first of kinematics. That means it is 5 plus 5, that is 10. It is 10 meter. Timing is how much? 2. I guess my answer is 5 meter per second. Easy or very easy? Easy or very easy? Okay, one more numerical. Numerical like length of minutes hand in a watch is 4.5 centimeter. Okay, find average speed and magnitude of average velocity of its tip between 6 to 6:30 p.m. So we are having a watch like this, 12, 6, 3, 9. So my watch is like this, right? It is 12, that it is from 6 o'clock means like this, a minute hand, and 6:30 would be like this. So what we have to find out, it is R. So radius is given as 4.5 centimeter. Done. So find average speed. Average speed. For average speed, it is distance by time. Distance would be, it is look from this part to this part, it is semicircular path, that is pi r. Time is t. Pi is pi. R. What is R? 4.5 now. It is 4.5 centimeter, 10 to the power minus 2 meter. And time is, what is time? Look, this minute hand take is 30 minutes to go from 60 to 6:30. 30 minutes. It is 30 minutes. In 1 minute, we are having 60 seconds. Done. So my answer came out to be pi divided by 1800. So we are having pi by 400. Not 400. 1 second. Pi by 4000. No. 1 second. 20 4. Okay. So if I just write in, it will go a great numerical here. So I will write here in centimeters. There is no issue, right? So that will become big now. Look. So I will write here 45, 18, 4 yeah, pi by 400 centimeter per second. You can change it now, na? Okay. Then average velocity. V average mod. It is displacement by time. Displacement is 2r. Timing is 2. What is 2r? 2 into 4.5 divided by time. Time is 3 into 60. Done. It is 1 by 200 centimeter per second. Done. If somebody will ask you how to write V average, how to write V average? Sir, displacement means final minus initial divided by total time. Finally, it is here now. Look, you can see my clock's arrow is towards 6. Towards 6 means downwards. So is it minus RJ? J cap, right? Initially it is upwards plus J cap. It is minus initial. It is RJ cap. The timing is 30. That is 1800. So you can write V average equals to, I can take minus R common, to be J plus J whole divided by 1800. Okay, or you can write minus 2 RJ divided by 1800, or you can write minus RJ divided by 900. J. It is in vector form. Done. Easy, very easy. Okay. Next numerical. A bird flies with speed 20 meter per second for 15 seconds. Due north plus J. Then it takes rest for 5 seconds. Then it flies with speed 24 meters per second for 10 seconds. Due south. Find first part. distance traveled. Find first part, distance traveled. Okay, a bird goes from, let's say, origin, it goes from north, came back and go towards the south. We have to find out this distance. Done. It is 20 meters per second for 15 seconds. So I can write distance is equals to speed multiplied by time. It is 20 into 15. Done. What is 20 into 15? Is it 300? Yes, sir, it is 300. I will write here 300 plus it is 24 into 10. It is 240. It is 440 meter. Total distance. It is distance. If somebody will ask you how to find average speed, it is distance 540 divided by time. Timing is 15 seconds. Then we are having 5 seconds. 50 plus 5 is 20. 20 plus 10 is 30. It is 30. 540 by 30. It is 18 meter per second. Third part. Displacement. What is displacement? Okay. Look now. A particle goes towards the right. It goes 300 meter upwards. 300 meter upwards. 300 meter. Then came how much? 240. It came back 240. 240. Here 240. What is displacement? Displacement means that the net of the two, right? That means, look, finally position is here. So is it 300 minus 240? Is it 300 minus 240? Yes, sir. It is 60. It is 60 meters. If in vectors, it will be 60 j cap. It's 60 j cap. Then, okay, fourth one, average velocity. Average velocity is displacement divided by timing is 30. It is 2 meter per second. Easy or super easy? Easy or super easy? Okay, now, if you will get a numerical like this, look now. V equals to 2t plus 3 speed. Okay, so find average velocity for time interval 0 to 3 seconds. Average. What is average? Average means the formula that we derived in basic maths, right? This was my formula. V average. Integration of V, that is 2t plus 3 with respect to dt. Initially is 0, finally is 3. Integration from 0 to 3, it is dt. It will be 2t cube by 3 plus 3t. Upper limit is 3, lower limit is 0, whole divided by, it is t, upper limit is 3, lower limit is 0. 2 by 3 into 3 into 3 into 3 plus 3 into 3 whole divided by 3. 1 3 cancel out, so we are having 3 3s are 9, 9 2s are 18, 18 plus 3 3s are 9 divided by 3. Done? One, okay, it is, sorry, one mistake is there. It will be 2t square, not cube. I'm going with flow now, that's why sometimes this issues happen. 1 second, beta. It will be 2t square by 2 plus 3t, upper limit is 3, lower limit is 0, whole divided by t, upper limit is 3, lower limit is 0, cancel out. So it is 3 multiplied by 3 plus 3 into 3, whole divided by 3, 9 plus 9 by 3, it is 18 by 3, that means 6 meter per second. 6 meter per second. Okay, next part. Okay, we know that my distance is always more than or equals to the magnitude of displacement. Divide both sides with time, so you will find average speed is more than equals to average velocity. One more formula, that is average speed is more or equals to the magnitude of average velocity. Okay, and it is average, huh? So v instant is equals to v instant. That means the magnitude of instant velocity, the mode of instant velocity and the instant speed both are equal. Both are equal. Done. So now let us do change in velocity topic. Change in velocity. We're having some time left, right? Change in velocity. Change in velocity. Suppose we are doing a circular motion with radius r. Particle is going with initial velocity vi, and here it is going with velocity v final. So let us connect both them. Okay, or like this. So this is my theta. It's my theta. So I have to find out this theta. How to find this theta? Okay, like change in velocity means delta v. Delta v means final velocity minus initial velocity. Nothing more than that. If final velocity mod is equal to initial velocity mod, so delta v is same. It is 2v sine theta by 2. Shortcut. Shortcut. Okay, let us do some numericals based on this particular topic. Then a particle is moving with 5 meters per second along south. Then takes 90-degree left turn and moves with same speed. Find change in speed or velocity. So velocity, right? Velocity. Find change in velocity. Okay. It is 5 meters per second south. South means minus j. Initial velocity is 5 minus j cap. Okay. Then takes 90-degree left. Left means east. Okay. Finally, it is 5 times plus j cap. What is delta v? V final minus v initial. Finally, it is 5 j cap. Initially, it is 5 minus j cap. So it is 5j. No, 5i. Sorry, it is 5. It is I. 5i plus 5j. Done. And what should be this mod? It is mod is 5 square plus 5 square mod. That is 5 root 2 meter per second. If somebody will ask you what is theta, it is p by b. So it is p by b. So if this is theta, p by b, this one is I cap, this one is j cap. So j cap, what we are having now? 5, it is 5, it is 1. So my theta came out to be 45 degree. East of south or south of east? One second. No? It is not east of south, right? Both are positive, no? Both are positive. So it is northeast, east north. Because it is not here, it is here theta. Look, why? Because here is I cap and j cap. I cap plus j cap. Then Now we are now with last topic known as acceleration. Known as acceleration. What is acceleration? It is velocity by time. Unit meter per second square. Dimensional formula m0 l1 t minus 2. And it is a vector quantity. Vector quantity. It could be positive, it could be negative, it could be zero. Positive, negative, and it could be zero. This is acceleration. Now types of acceleration. We are having uniform acceleration. Uniform acceleration. It is a vector quantity. Uniform acceleration. You need to write magnitude plus direction. If magnitude as well as direction remain the same. So this type of acceleration known as uniform acceleration. Now non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration means if magnitude changes, or if direction changes, or both changes, this particular thing is for non-uniform motion. Look, if velocity and acceleration both direction is same, so it is speed up. Look, here velocity is negative, acceleration is also negative. This is also speed up. If velocity is, let us suppose, positive, acceleration is negative, it is speed down. Or if velocity is negative, acceleration is positive, still speed down. Done. Now we are with, it is very small topic, we are with average acceleration. What is average acceleration? It is change in velocity by time. That means velocity final minus velocity initial by time. Done. We are having last part known as instantaneous acceleration. What does instantaneous acceleration means? So it is dv by dt, or it is v dv by ds. These two formulas you need to remember. Or you can write d square s by dt square. Some formulas for it also. Okay, let us do a numerical, then we can just end today's session. A numerical. A particle goes towards east and speed is given as 20 meter per second. Timing is given as 10 seconds. Then goes upwards. Speed is same, 20 meter per second. Timing is same, 10 seconds. What is change in velocity? So change in velocity means velocity final minus velocity initial. Finally, it is going towards upward, so I can write v and it should be in plus j cap. Finally, initially is v, which is going in plus I cap. So can I write now, towards the east plus I cap, that it means upwards, right? So can I write here 220 j cap minus 20 I cap. What will be delta v mod? 20 square plus 20 square root. It will be 20 root 2 meter per second. What will be acceleration? Acceleration average. Delta v by delta t. Delta v is 20 root 2. Delta t is 10. It is 10 root 2. Sorry, 2 root 2 meter per second square. It is 2 root 2. Okay. Now with this topic, we are done with today's class. Tomorrow we will start we'll start application of calculus. We will start application of calculus tomorrow. Okay. I hope you enjoyed today's session. If you are having any doubts or anything like that, you can reach out to me via Telegram. Until then, bye beta. Take care. Bye. Good night. One second. So we are done. Thank you, beta.